a tube. Now let me kind of bring this together based upon the tubes and the fluids. This is what we get. In the cochlea, the snail portion for hearing, all right, because my semicircular ducts are going to be for equilibrium. My cochlea, which does the twist, the circle. Think about if you could take that and roll it out. Is everybody with me? And then I cut through it so that I can get a cross-section view. This is what it would look like. I would have outer portions. So if I took it and rolled it out, okay, the outer portions of it would be my perilymph. The middle portion, the inside portion of it, is my endolymph. So if I had that tube, I wish I had a tube. Okay. Think about me where I've uncoiled that cochlea all the way out, stretched it end to end. And now I've cut it, and I'm looking through a cross section. These outer sides are going to be my peri, and the inner portion, my endo. So think about that type of structure rolled back up into the snail-looking part, okay? So what I'm ending up with is all the way around that cochlea. The outer sides of it are my perilymph that are going to function for protection of the endo portion, because my endolymph contains my sensory cells. Okay, so that perilymph, endolymph contains my sensory cells. They refer to one side, anterior, posterior. They got very inventive in lab that day. Upper is considered the scale of the vestibule, so scala vestibuli, scala tympani for the posterior, for the inferior side. So this middle portion where I have my endolymph, I have what's termed tectorial membrane. If I take this little section and bring it right here, where it's kind of got a blown up view. This tectorial membrane, is everybody seeing that? It's gelatinous. It's like a gel. However, what does it look like it has embedded into it?
Cilia?
Cilia. Cilia come from where?
Nerves.
A cell. They're always associated with a cell. In this case, nerve cells. My cilia to the nerve cells for the cochlea to receive the sensory information to pass it to the area of the brain that it needs to go to are found at this part of the cochlea. Is everybody with me?
Is that what happens when they bend?
Not yet. That's going to be with the semicircular ducts, like bending over, you mean like rolling, tumbling, up, down, front, back.
They just said in the study guide what actually occurs when the stereocilia.
Oh, when the stereocilia bend. Hold on to that thought, okay? Now, let's think back to what we just said is supposed to happen when the air wave brings in the sound, okay? When the air waves bring in the sound that are going to bounce on the tympanic membrane, which are going to make my ear bones move. Those ear bones move, and it looks like they begin to contact or come into contact with the portions of my inner ear. Based upon the structure that we just looked at for the inner ear, all right, to the outer portions, I've got peri. To the inner, I've got endo, which contains my sensory cells for hearing, meaning they are connected to the cochlear nerve. Is everybody with me? So, if these begin to move, this begins to boom, 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 boom. If this outer side, the outer portions, contain the peri-lymph, and this is now getting boom, 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 what do you think it's going to do to the peri-lymph to the outside?
Vibrate it.
Vibrate it, and that's going to make waves. Is everybody with me? So I'm making waves on the outer side of it. What do you think that's doing to the middle of it?
Vibrating it.
We're vibrating it. If I am vibrating it, I am making a mechanical, which is what this sensation is. I am making a mechanical movement, and it's going to affect the tectorial membrane. If my tectorial membrane begins to have vibrations in it, and we said what was embedded into it?
Cilia.
The cilia. Guess what?
It transmits nerve impulses.
Why? Because if my tectorial membrane is gelatinous and it has cilia in it and it begins to move, what is it going to do to the cilia?
Move them.
Move them. it is going to cause that projection to move, which is going, because it's attached to the nerves, the cells for hearing, it's going to start the action potential. The goal of the perilymph that goes all the way around it, dampen the sound so that the sound is not so great that it breaks those cells, those cilia. Is everybody with me?
Is like when you hear like the ringing in your ear, is it an irritation to the cilia?
The tinnitus in the ears. Usually what has happened is you have damaged those hair cells and they don't recover. And so you get whatever sound or whatever range that was at, and you end up with the ringing of the ears. So now, if that is what is happening, like I was saying, in that cochlea, if I stretched it out, recognized my perilymph, the scalas, the vestibuli of the tympani, okay, that's where it's going to dampen the sound around the middle, my endolymph, okay. We're going to get to this cochlear duct because the cochlear duct being in the circle that we're going to have, all right, we're going to see that the perilymphs are separated by a membrane to the endo. We've got the basilar membrane, the part with the cells, okay. We've got the endolymph. We've got what our organ of hearing is. The organ of hearing is termed the spiral organ. All right, that is our organ of hearing. It is sensory material because those impulses have to be picked up by these sensory cells, which are going to start my action potential. So if I get the vibrations that are coming in and they make their way to the movement of that tectorial membrane, the cilia that are embedded will begin to bend. When we talk about this structure of the hairs, we're going to find that we have IHCs, inner hair cells, and then outer hair cells. So the area in that endolymph, that part of the membrane, that epithelium that is specialized, contains the hair cells. Up to this point, okay, we've mentioned cilia. Well, these are going to be very stiff microvilli, and if you remember, microvilli are projections that come out of a plasma membrane. They tend to be thick and a little bit tough, okay? And we're going to know these as stereocilia, the projections into that tectorial membrane. The gelatinous material. We got inner, we got